All right. Now, let's examine the physical setup of the particle in a box experiment. This experiment will use almost exactly the same equipment that we used for the hydrogen atom spectrum experiment. Only now we're going to be doing an absorption measurement of a quite different sample instead of an emission experiment on an emission lamp. What that means is that we're going to do an absorption measurement, or equivalently a transmission measurement, on a sample. In this case, for the purposes of this video, I'm going to show you the transmission spectrum of this green dye. Okay? So I have a sample of the green dye here, and what we're going to do is to place that between a white light source and our spectrometer and see which wavelengths of light the green dye absorbs. To begin with, we have a transmission attachment for our spectrometers that contains a white light source and is also designed to hold these cuvettes. So let's go ahead and place that in, and I'll attach it. As simple as that for this equipment. And then we can start the program in order to take our measurements. So we'll start Logger Pro once again. All right. And now we're going to make sure that the experiment units, can we get to them here? Yes. No. Terribly sorry. Let's go back. That the units of the experiment, spectrometer mode here is transmission. There we are. That's what we wanted. And now we can go ahead and close this. Okay. All right. Next, remember that every transmission measurement actually contains two measurements. A measurement of our sample, this, but also a reference measurement, a measurement of the spectrum of the source and any other components in our experiment. The way this equipment is set up, we'll start with a reference measurement, and we're going to measure a cuvette that contains only water. So let me place that in the system, and then we'll have the system carry out a transmission measurement, and this one will be for calibration. Start collection. And the first thing that it does is it just brings up this box. You can't read this, but it says calibrate spectrometer. It knows it's taking a reference measurement now. And then it's also asking us to wait for 1.5 minutes while the lamp warms up and stabilizes. And that's a good thing to do, but you don't have to wait. Let's skip to the end. Okay, the warm-up is complete, and we can finish the calibration. Okay, and we're done. And you can see now, I'm not sure if you can easily see it, but the spectrum right now looks like a flat line at 100%. Let me just rescale this. Oh, wrong. Let me do that. Okay, now you can see it's a flat line at 100%. That's because we're taking the spectrum of the reference sample and dividing it by our stored spectrum of the reference sample. Finally, to do our transmission measurement, we simply remove the reference sample and replace it with the actual sample. Okay? And it looks great. This sample has a strong absorption line, which has its peak at about 490 nanometers. Okay? The line is very broad compared to what we saw for gas samples, and that's typical of liquid samples, where we have many molecules close together that are interacting with each other. All right, well, that's all I wanted to show you. So let's stop.